Hi, in this video we solve question number 11 of IIT JAM 2021 mathematics paper. Here's the question. M and R is the real vector space of n cross n real matrices. N is greater than or equal to 2. A is any arbitrary matrix and W is the vector subspace of the given space spanned by the powers of A. Now M and R has finite dimension. In fact, its dimension is equal to n square because n cross n matrices have n square entries. Right. And we know that any subspace of this vector space cannot have infinite dimensions. So option A must be wrong. Also, what we do is take A as the identity matrix. The special thing about identity matrix is that all its power is also identity. So this implies that W is actually the span of this single matrix identity, which implies that its dimension is 1. Now 1 is strictly less than n because n is given to be greater than or equal to 2. This means that options B and C are wrong as well because 1 in this case is neither equal to n squared nor equal to n. So it leaves D as the correct answer. But why should D be the correct answer? If you're wondering, here is a quick proof. Remember that if you're in exam, you're already done with this question, so you can move on to the next question. Now, to understand the proof of this correct answer, we recall the well-known Caley-Hamilton theorem. What does it tell us? It says that every square matrix satisfies its own characteristic polynomial. Now, what is the meaning of the word satisfies? It will be clear in a moment. Now, the characteristic polynomial of a matrix is defined as follows. It is given as Px, which is the determinant of A minus x times identity. Now, this is a polynomial of degree n, which means that Px can actually be written as a0 plus a1x all the way up to an times x power n, where an is a non-zero scalar. And the theorem says that P of A is equal to 0, which means that if you replace x by A, you get this equation satisfied. Now from here, you simplify, take all the lower terms on the right hand side, you get this equation. Now divide both sides by an because an is non-zero, and you get an in terms of linear combinations of the lower powers of A. So this means that an belongs to the span of all its lower powers. Also, an interesting thing to notice is that from this equation, if you multiply both sides by a, what you get is a power n plus 1 also belongs to the span of a power 2 all the way up to a power n. Now a power n, we know that belongs to the span of the lower powers of a. So this means that this span is a subspace of the span of all these lower powers of A up to n minus 1. Now going on like this, you can argue that A power k actually belongs to the span of these lower powers up to n minus 1 for all k greater than or equal to n. Very good. Now this tells us that W is actually the span of identity A up to A power n minus 1, which means that W is spanned by n elements. And this means that the dimension of W is actually at most n, and this gives you the correct answer, D.